everyone, so I just want to go over the statistics review packet with you. The first question here, Miss Wright's algebra class consists of 28 students who recently took a 20-point quiz on factoring, and here's the distribution of scores on the dot plot. So the first question, which of the following is closest to the percent of students who scored less than 16 on the quiz? So remember, less than 16, you'd want to count up all these dots. There's going to be 8 dots, but 8 out of the total 28 times by 100 gets you to your percentage. Okay? Number 2, which of the following would be the median score for the data? So instead of typing this all into the calculator, you want to kind of work your way in, or even do 28 cut in half to figure out the halfway point. And as you find those points, so there's 4, 2, and 2, and then there's these 4 here, so it's 1 and 1, so it's exactly right in the middle at 16 and a half. So that's what we want to get for number 2. The average of 16 and 17 is 16 and a half. Which is the range of the score. So the range is going to be the highest minus the lowest, 20 minus 12, so that's 8. And then for number 4, the high temperature in March in Dutchess County, shown in the box plot below. What is the median high temperature? And we want to know that that is the median right there. So if you look, it should be, looks like it's 2, 4, 6, 8, 10. So the little tick marks are every 2, so 32, 34, 36. Choice 2. On the next page, a local babysitting group takes care of 8 children on Saturday morning. The children's ages are shown below. They want to know the mean. You want to make sure that you know the mean is the average. You're just going to add them all up, divide by 8. Number 6, this is our box plot. We want the interquartile range. That's going to be from Q3 minus Q1. So the start and stop of the box. And that's going to be 80 minus 20, so that answer is 60. 7, which of the following is data sets would have a standard deviation closest to 0? Remember that the standard deviation tells us how deviated, how varied the data is. So a very, very high standard deviation is going to be a wide spread. So if we want something closest to 0, we're looking for the smallest variation possible, which is going to be choice 3 right here. All the numbers are closer together than the rest. Number 8 is a calculator question. So what you're going to do for number 8, a sample of 10 large eggs were weighed with the results shown below in grams. Which of the following is this sample's standard deviation? So as you go to your calculator, you're going to want to press stat and then enter on edit and type into your list. And then just make sure you typed everything in. You have all of them correct. And we have 10. So now you're going to stat over to calculate and enter on one variable stats. And right here we have our mean. We have the, some information here. And then we want to go here. We want it says the samples standard deviation. So that's with the S sub X. If they just said population, then you would choose the other one. So this one is 3.5, which is close to, or which is exactly what we want here for our number 2. Okay. Number 9, a survey of 52 graduating seniors was conducted to determine if there was a connection between the gender of the student and whether they were going to college. Which of the following represents the proportion of those who are going to college who are male? So the number going to college that are male, there's 16. First of all, going to college, there are 29 total people going to college, and 16 of those 29 are male. So 16 out of 29 is 0.55. Number 10, which of the following correlation coefficient values below indicates the greatest correlation between two variables? So the best correlation between two variables means that when you're looking at your scatter plot, that the plots or the points are all really, really close together. So which of the following would be the better correlation? You want it very, very close to positive or negative 1. So with this question, they're kind of testing you to see, are you going to choose the highest positive, or do you see over here that this negative is the highest negative that you want? So again, you want to choose the number that's very, very close to either positive or negative 1, and that's going to indicate the best correlation. Number 11, 4 different types of regression were used on this data set. Which of the following 4 residual plots shows the model that's the most appropriate to use? We definitely don't want any sort of pattern with our residual plot. So 3. It needs to be random. All the rest have a pattern. Number 12, they've given us a equation based on the price of the barrel, the equation they find. So they're doing their linear regression. One of the data points they use is 60, 3.62. What's the residual? So we've got to make sure we remember what a residual is. The residual is the observed, or we call that the actual, minus the predicted. So this is the actual, and then we have to subtract it from what the predicted one would be from this equation. So if we take 60, we substitute it in for x, so you could see the work here, 60. They got 3.05 when they reduced it. So then we take our actual, 3.62, minus the predicted that we got when we plugged it in, 3.05, and we get the residual of 0.57. Number 13, which correlation coefficient is most appropriate? Well, definitely negative because it's a downward trend, so it's not 3 or 4. And you don't want to, usually you never pick positive or negative 1 because then that would mean all the points are exactly in a straight line. And we see that they're obviously a little bit off. These will all connect to a straight line. So negative 0.92. Which of the following scatter plots most likely indicates a quadratic regression? So which one looks most like a quadratic? It'll be choice 3 right here. All right, so this next question, a local summer art camp admits kids from ages 5 to 13. In the summer 2015, the camp had the following distribution of age groups. So what percent of kids attending are less than 8 years old? So you have to find 6, 7, 8. Less than 8, 1, 2, 3, 4, 5, 6. So 6 out of the 25 times 100 gets us to 24%. Which is greater, the mean or the median? So what we're going to do for this, we're actually going to enter into the calculator to find our mean and median. There's a couple different things we can do. You could type in, like you see here, 5, 5, 6. You can type them all in. We also discussed that you could type the frequency of them into the other list. So I'll go ahead and do that just to show you. So that's going to be 6, 7, 8, 9, 10, 11, 12, 13. I think that's what it goes up to. Okay. So now we're going to say we have 2 dots for 5, 1 for 6, 3 at 7, 4 for 8, 3 for 9, 2, 4, 6 at 10, 3 at 11, 2 at 12, and 1 at 13. So when you do type the frequency in, you have to make sure to tell the calculator that that's what you did and that's what you want to use. So if we're going to go stat, over to edit, one variable, and then here we'll see frequency list. So make sure we put our L2 in there, and then it will calculate it for us. So there's our mean, 9.04, and there's our median, 9. So the mean is higher just by a little bit than the median. And so that's what we want to say there. If we enter the data into our calculator, we find that the mean is larger than the median. What is the interquartile range of this data set? So if I go back to my calculator, my interquartile range is going to be 10.5 minus 7.5. So that's 3. Show how you calculated it. Again, show all your work. Part D says sometimes data sets are broken into quintiles, okay? So normally we say quartile because we're breaking it down into 4s. The quintile is 5, so breaking it and dividing by 5. So it says which group Which are the groups that have 1/5 or 20% of the data in the sets? So again, if you thought about it like 100% divided by 4, which is why we had, like 25, 25, 25, 25. But if we break it and we divide it by 5, we're going to get groups of 20. So it says, which ages would the upper quintile contain? Explain how you determined your answer. So what we have to do is, if we know, they told us at the top that there are 25 participants in the camp. So if we took our data and we cut it into fifths, we're going to have 5 groups of 5. So, the lower 5, then the next 5, and the next 5, the next 5, and then the upper 5. So it says, which ages would the upper quintile contain? So if we go look back at our data, we would have 1, 2, 3, 4, 5. So it would be this group. Yeah, so it'd be this group of data. So we'd say 13, we'd say 11, 12, and 13. So those are the ages, 11, 12, and 13. If they said the lower, we would do 1, 2, 3, 4, 5. So we would do 5, 6, and 7, and so forth. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So it just broke it down into groups of 5. You could even see this easier if you wrote all of these out and then grouped by 5s as well. Okay, and then the last one here, the box plot shows the distribution of ages. Which of the 2 camps has a greater age range? So here we have 15 to 3. So 15 to 3. It's going to be 12 years. And then up here we have 13 to 5. So 13 to 5 had 8 years. So the farm camp had a greater range. It went from 3 to 15, so that's 12. And the art camp only went from 5 to 13. So we want to say the farm versus the art camp. All right, our frequency table here. So a marketing company did a survey of 400 people with ages from 12 to 20 and broke them into 3 age categories. And they each person tried 3 colas and specified which was their favorite. So we want to find the relative frequency of a person choosing each of the following as their favorite. So for cola A, we found 6 out of the 40 liked cola A, 22 out of 40, 0.55 like cola B, and 12 out of 40 liked cola C. So just remember that relative frequency, you need to have those decimals to see that, the percentage as well, if they wanted the percent. Is a person in the 15 to 17 age range more or less likely to choose cola B as their favorite compared to the others surveyed? So now we're getting a little bit more specific. We want to figure out how many people from the 15 to 17 age group. So there's 13 total people in that age group. 8 of them said that they liked cola B. So if we do 8 out of 13, we get 0.62. And that was higher than the rest. So the frequency here is 0.62, which is greater than the overall population surveyed, which was 0.55. So if we're comparing these two, the person that is in this age group is more likely to choose cola B. C, which is more likely? A, that a person who chooses cola C as their favorite is in the 18 to 20, or B, that a person 18 to 20 chooses cola C. So this is the different scenarios. So if we go back up here, scenario A, we want to say a person who chooses Coca-Cola as their favorite drink is in the 18 to 20 age group. So for our Coca-Cola A, we want to go, or is it C? Oh, sorry, C. So Coca-Cola C, we have 12 people who like that. And 18 to 20. So 7 out of those 12 people. So that's how we got the 0.58 for the scenario A. Scenario B says that a person in that age group, so first of all, in that age group is 17 who likes it as their favorite. So that's 7 again. So this is 7 out of 12 because we're looking at just the 12 people who are liking Coca-Cola C out of, and then this denominator is how many 18 to 20-year-olds we have total. So obviously we see that this 0.58 scenario A is more likely. So it's more likely that a a person who chooses Coca-Cola C is in their 18 to 20s. The company will only stock vending machines at the mall with a particular soda if more than 25% of at least one of the age groups chooses it as their favorite. Will any of the 3 colas be excluded based on this criteria? So if we take a look, Cola A, in the 12 to 14 bracket, we have 3 out of 10. So again, going up here, 12 to 14, we have 3 out of 10, so it's 30%. And then Coca-Cola B, we have 8 out of 13, which is 62. And Coca-Cola C, we have 7 out of 17, which is 41. Again, the company will only stock the vending machines at the mall if more than 25% of at least one of the age groups chooses it as their favorite. So no soda will be excluded. We can see this by analyzing the largest percent that each soda gets amongst all 3 brackets. So that's why we chose those particular values. So if we looked at Cola A, 3 was the largest. So we're going to figure that out. Here we did 8 just because 8 was the largest for that. And then here was 7. So that's why we tested those 3 and then said we were able to say we're not excluding. All right, so for this next one here, we have our linear and our exponential regressions. I know we did this in class, but I want to go back over it again. Clear the list, and then type in our data. Now, this is not one variable stats. We're going to do our linear regression. So stat over to calc, choice 4. We need to take this out and delete it because we're not counting that as our frequency list. And so that's how I got this answer right here. 14.5x plus 11.5. They said round to the nearest tenth. Then I'm going to do it again to get the exponential. And so there we go, the 23.8 and the 1.3. So the correlation coefficient for both models when rounded to the nearest hundredth is 0.99. What does this tell you about the predictive ability of these models? Remember, the 0.99 is saying that these points are highly correlated to one another, so they are going to be very good at predicting. So both these models have excellent predictive ability because of how close they are to 1. Part C, does your linear model from part A overpredict or underpredict at 6? So up at the top, we see 6 was supposed to be 100 shares. That was the actual. If we use our linear regression, because it says linear model, linear regression, we are going to plug in the 6, and we get about 98.5 or 99. So the model here underpredicts by 1. So it underpredicts what the actual is. And then for part D, after 24 hours, the post had been shared this many times. Which model does a better job extrapolating the data? So remember, extrapolating is when we are looking to see what happens after this data set, and interpolating would be what's going on the inside. So if we substitute a 24 into both the linear and the exponential, see what we get here, and then we can correspond it to what they told us this was the actual. So they told us that this would be the answer. So this one. So although neither model is really very close to this, the exponential one would be the better choice of what actually will happen. Number 18, a linear regression was done to relate the age of person X and the number of optimal hours of sleep Y, and that equation was found, our correlation coefficient, negative 0.86. Explain what each of the parameters in the linear model represent. So the parameters meaning the A and the B values. So it's really important to make sure that you are being able to explain this in terms of the question. So it says a linear regression was done to relate the age of a person, X, and the number of optimal hours of sleep, Y. So we have to talk about those two things. So first of all, the 11.5 indicates that's like our starting amount. And again, if we put into the calculator, into the regular Y equals, and looked at the table, you would see that it says 0 at 11.5. So you could say when the age is 0, 11.5 is the optimal hours of sleep. So at 11.5 indicates that a person who is 0 years old or a newborn has an optimal number of hours of sleep of 11.5 hours. The negative 12, we have to figure out what that means as well. You're not going to see that on here, but that's how much it's decreasing by. And that's over a positive 1, remember? If we want to write that as a fraction. So the negative 0.12 indicates that for each year a person gets older, again, 1 year older, the optimal number of hours of sleep goes down by 0.12. So make sure you're able to talk about both of those. How did you interpret the fact that the correlation coefficient is negative? Well, the negative correlation coefficient indicates that the age of a person, as the age of a person increases, their hours of optimal sleep decrease. So we had to, we could have put this in the calculator. Well, we did. And if we were to graph it, we could also say that we saw that it was a decrease. We're actually not going to see it, I don't think, because it's up here. But if we zoomed out, enter, there we go. So we can see the line going down. And the negative right here tells us that it's going down. So the negative correlation coefficient indicates that it's going to be a decrease, as well as our negative for the slope. All right, so number 19, severe flu cases are increasing at a local hospital. The number of reported cases is shown over the span of a week. So we have our X and our Y. Determine a linear regression model that fits this data. So we'll go in stat edit, clear, 1, 2, 3, 4, 5, 6, 7, and then 13, 19, 24. Stat over linear, and then that's how we got the 3.4 and the 12. So that's our linear regression model. And then it says create a sketch of the residuals below. Discuss whether this plot indicates that a linear model is appropriate or not to fit this data. So remember what we're going to do is we have this equation and our residuals are the actual minus the predicted. So if we go into our y equals, we clear this out, we put in the predicted and look at the table, we can say, well, 1, the actual was 13, but our equation says it should be 15.4. So I'm just going to write these down. 2, 18.8, 22.2, 25.6, 29, 32.4, and 35.8. Okay? And then I'm going to subtract them. So 13 minus 15.4. So now these are my residuals. So negative 2.4 is the first one. 0.2. Okay, 1, 2, 3, 4, 5, 6, 7. So once I subtract all those are the residuals. So remember, the residual is the actual y minus the y we get from the equation. And then we go ahead and just plot them. Again, you're not going over so far. It's the first tick mark is the first residual, and you're just saying the first residual is down here close to 3, and then the next one is just a little bit above at 0.2, the next one is at 1.8, the next one is at 1.4, the next one's at 1, the next one's negative, a little bit lower, so negative 0.4, and then the last one is at our negative 1.8, so down here. All right, so this plot indicates that a linear model is not an appropriate fit. Again, there's a pattern here. A residual plot such as this shows a pattern, so it indicates that some other model, maybe an exponential, would be more appropriate for this data set. And as you get into Algebra 2, you're going to try to figure out which one will give you the more appropriate based upon the residuals and also based upon your correlation coefficient. So you kind of knew up here that the correlation coefficient wasn't that great. It was an okay fit, but not a good fit or a very good fit. And then here it just proves that it definitely wasn't a good fit. Okay? All right, so make sure you go through your note packet. Let me know if you have any other questions. And make sure we know how to use the calculator. One last thing I just want to make sure you're able to do is I do have these in there. So in order to see the scatter plot, remember we have to turn our plot on. So you're going to press second y equals, enter to turn it on. This is already selected at scatter plot. Everything's in list 1 and list 2. So if we now press graph, we were able to see it. However, it's not the best look. So remember, to change the window, we would go back and we would look at our table here. So that would be 1 to 7. So I maybe do 0 to 8. And then the minimum for our y, maybe do 10 to 35. So there's what I did there, just based upon it. And now I see our graph. Okay? So this would be our scatter plot if we had to do a scatter plot, and then there's my line of best fit that I typed in that will go through it. Okay? Alrighty. So again, thank you for watching. And let's see. I want to do a quick little bonus. So for anybody who is watching the video, if you have watched it hopefully all the way through, we'll do the bonus word alpha. So alpha will be the bonus word, and I will ask for it on the test. And if you write it down, you'll get 2 extra bonus points on the test. All right. Have a great weekend. We'll see you later.